Fantastic. Sounds great.
Yeah.
Okay, so that's a small scale. I noticed in looking at your website, you've got replacement packs for the Nissan Leaf, which really surprised me, the price point on that.
Well, thank you. That's the
Yeah,
point. It's supposed to surprise you.
because I know what I just paid for a 1.6 kilowatt replacement pack for my Prius. So
Uh-huh.
I can, of course, part of that was obviously the cost of the labor and things as well. But so then you've got replacement packs, and maybe we want to talk about that. And then also you've got some power lights, portable solar trailer kinds of things. So maybe let's talk about those a little bit.
Sure. So the smallest product that we sell is right here, right? Now
right.
let's go bigger. Now that I got you on this phone,
Oh,
I can
goody,
show
we
you
get the tour.
Yeah, we're going to go give you a tour here. Let's
right.
show you some other. So here's an example. Here's an example of an NEC pack, okay? This pack, we put this in golf carts for a DIY golf cart conversion.
Right.
5 kilowatt hour, weighs 100 pounds. And these packs are light years ahead because there's no maintenance. They're going to last for 7 years without maintenance.
Right.
This right here also is for golf carts. 60 volt. You can use it for, these are what we call our blocks right here. So it's basically LG chem cell packs that are in a modular form factor using an Anderson connector. Here is my product from Nissan. So these are all Gen 2 Nissan modules in a singular, just one block, right? If you want to do solar power at your house. But let's say you're in a big company, right? Here's my big boy.
Yeah.
All right, so this guy, if you look inside, you can see our modular blocks. You can see that we use a PCB board to run all of the wiring. So the wiring, let me see if I take one of these off to show you here.
Right.
Bolts directly on. The Nissan modules bolt directly on to our PCB. And the benefit of this unit is if there's ever any problems, we can take this unit and just replace one module.
Right.
I can send you one module to fix any problem that you have rather than needing some fancy technician to come out. So from here, these are 28 kilowatt hour units, right? Let's lock this guy up here. It's hard to hold the phone and do it.
Right, so exactly. Hey, let me ask you, these are you using any nickel metal hydride or are these all lithium?
These are all lithium ion.
Okay.
And then on the back, obviously, you have your readouts for each individual line in series and parallel. I'm running at 48 volts here, and then you have your breakers and your solar inverter on the back.
Right, right.
So this is great for peak shaving, especially in places like California, where in my office we have demand charges that equate to about 28% of my bill.
Yeah.
Yeah, so that's kind of where we're going with the big boys. Okay. But let me show you some of my power walls here. Let's take you on a tour. Here's an example of one of my power walls.
Okay.
So this guy right here is an LFP battery. We got 100 megawatt hours of these guys in. They come with our proprietary BMS. And there you go. The entire unit takes 10 minutes to build.
Wow.
From garbage to a new product, we slot it in here and it takes 10 minutes to build that unit. And I'll show you the building process, actually. There's Eddie. Say hi, Eddie.
Hello, Eddie.
Say hi, guys.
Hi.
Hi. Let's take you on a tour back here of some more products. So up here you can see these are all of our certified electricians in the building right now.
Right.
We're gonna take you out back and show you some batteries.
Okay.
Here is some batteries.
Oh yeah, there's a few.
Just a few.
Now, do you deal directly with the manufacturers, or is there this comes through some middlemen?
I can't name the companies, but you can say that in one way or another, whether it's through recyclers or through the OEMs direct, we're getting about half of all of the EV industry batteries in the door.
Okay.
From Nissan, Nissan, here's an example of what 3,000 Nissan packs looks like.
Wow.
Yeah, and it just keeps going. And if we look inside, you can see just row after row after row. I'll go in there and show you. But all these Nissan packs, we are going to process. And when we process them, here's the processing. We're talking about bottom balancing all of the Nissan modules inside. The bottom balancing process. These are all Gen 1s, for example.
Okay.
Right? Gen 1s. Here's some Gen 2s for Nissan. You know, every single car company, we get their batteries one way or another. You know, just everyone except for Tesla.
Yeah.
Right?
Now, is that why do you think that is?
Oh, why don't we get Teslas?
Yeah, I would suspect it's on Tesla's side, obviously.
Here's an example of the recycling process. When we're done, this goes out for true scrap commodity recycling because it's proprietary parts and components, right? So all the wire and cabling and plastic and ABS, right?
Right.
And in that process, what you end up getting to keep all of the modules.
Okay.
Which then are able to be packed up. And after we test them, we pack them in number 9 boxes, and out they go to the DIY community. Mm. Yeah, let me keep showing you. This is a 100,000 square foot facility, so it's going to be a lot of
walking,
a lot of batteries. Yeah. It's just it looks like that scene from Indiana Jones in certain parts.
Yes, exactly.
Stacked up to the roof, you know.
Some of the Ark of the Covenant in there somewhere.
Yeah, that'd be a easy way of saying it. The facility goes over there. That's all just one. I can't show you over there, but it's another car company. Here's an example of just boxes.
Yeah.
Now let's show you something other than boxes. Let's show you processing. So here's an example of a tester that we have. Let me pull this out. Oh, I can't. It's too heavy. All right, here you go. So this is a bottom balancing unit, right? Right now we're running Hyundais on that unit. Here is a manufacturing process for, these are my power walls. So if you look inside here, you can see our BMSs, fuses, Anderson connectors, thermal regulators, and it's just one solid unit where 90% of this is a single LFP battery inside of a shell running 4.2 kilowatt hours at 24 volts.
Okay.
We're making 8,000 of these units. And when they're done, they're packed up like this.
Now, these are typically are these going overseas? I mean, where's your biggest market at this point? Here in North America?
The biggest market's overseas.
Okay.
Specifically, we find a lot of customers currently in Australia and India.
Okay.
Here, I had a call coming through, sorry.
That's all right.
Again, here's an example of the blocks, right? And here's an example of the power walls.
Yep.
And here's an example of units being put together, as you can see here. And then here, this is shutting one up, but give you a look inside, what's under the hood, right?
All right. Thank you.
Now, no worries, it's fun. Let me give you an example of our PCB. Do you have one of our PCBs that I can show? Great.
Now, what is a PCB?
Printed circuit board.
Okay.
So we manufacture these overseas, and the purpose is I could run 110 amps across this.
Okay.
Which means it's dummy proof. We offer a tutorial online on YouTube of how you can directly connect to our PCB And as you can see here, you can run data across it as well so that we can connect this directly to our BMS. So it leaves no room for failure when it comes to people wanting to build or maintain or work on these in their homes if you run them on PCBs. I mean, it's just, it makes it all hot swappable and easy.
Okay.
So that's an example of, here's one of our block units that's currently being manufactured. I just want to show you what the inside looks like, right? As you can see, they're just, the entire unit, again, if we take this off, here's the PCB.
Right.
So that's, and you can see your BMS plugged directly in, and it's just nice and clean and generic and easy to work on and non-proprietary and not meant for planned obsolescence, because I hate planned obsolescence. I'm a believer that we need to build things to last. There you go.
Very cool. Yeah. All right. Well, thank you for that tour. So your biggest market, what's the biggest market for you at the moment? Is it in the small power walls or the golf cart conversions or the lighting systems?
Well, I'm glad you asked. The biggest thing that we're working on right now, I'm taking you outside to show you.
Right.
Here, let me turn the camera around for a second. Can you see this right here?
Okay, I'm still seeing you. Okay, there we go. Yep.
So these are our power trailers. So what you're seeing here is a 60 kilowatt hour solar power trailer.
Okay.
Okay. We're building 142 of these units currently here in Chatsworth.
All right.
And we're hoping to work with both the state and local city officials to launch these all across California. And we're using recycled EV packs.
Wonderful. Cool.
Yep. On a 10,000 pound trailer, dual axle, with all the bells and whistles. You can see a couple more here. There's, with solar power lights.
Right.
Right? This is the future of battery recycling right here, and it's just fun to be able to show you. In certain cases, we'll put generators on board, right? So 11 kilowatt hour generators and SMA inverters inside.
Right.
So here's an example of what's under the hood again. But this is 142 of these units are currently up on bigbattery.com, and we'll be pumping out a lot more of them. But it's interesting because, again, one of these units, usually if we had to manufacture it, would cost $30,000 to $40,000. Well, we don't have to pay for the batteries. So because we're not paying for the batteries, I'm selling these things for $15,000.
Okay.
The whole trailer.
Yeah.
So it's about making things affordable so that people can actually get the newest technology. So that's one of the big things that we're working on right now at Big Battery here.
Yeah, hey, just curious, is that a RAV4 EV back there?
Yeah, that is.
I thought so. It looked familiar.
And here's our car that we built.
Yeah, talk about that a minute.
Well, the Phoenix was a fun project. Basically, it's the world's longest range electric vehicle. It's made from over 89% recycled material by weight. And it went 999.5 miles back when EVs, the longest range is 300 miles.
Yeah.
So it had a 142 kilowatt hour battery pack, seats 2 people, and can travel at 80 miles an hour continual for 748 miles. We already proved that with Guinness.
Right.
And then we took it to the track and we did 999.5 miles. Something fun you can see.
What was the average speed?
28 miles an hour.
Okay.
To do half a mile short of 1,000 miles. But this is kind of fun to show you. You know, from LA to Phoenix, 4 cents a mile.
Right.
So LA to Vegas was $14, but LA to New York's $123. That's just, and it's made from all recycled parts. So when we first started, our goal was 400 miles, but we went a little bit farther than that.
A little further, yeah. Excellent.
Yep. So Guinness Book World Record holder, this car, and the whole purpose, again, was to kind of promote EVs and make sure that the world understands that you can recycle this stuff. You don't need to throw it away. It can serve multiple life cycles for the benefit of mankind.
So to sort of summarize, you are offering small packs for sort of for solar applications for either recreational or backup power for if the power goes out for people in their home. Then you scale up. You've got some EV applications from golf carts to Nissan Leaf replacement packs. And then from there, you've got the larger sort of scale versions of power walls, and then finally you've got the solar powered trailers.
All of that is correct, yes. And the whole purpose is to make sure that this stuff doesn't end up in a landfill, but that we can reuse these battery packs and find a solution. Because if I'm able to breathe 2 extra life cycles into a pack, now we can divide the carbon footprint by that, whatever it took to manufacture that pack, right? So the end goal is to make sure that we have a solution in America to actually reuse all of our value instead of just throwing it away or dumping it or hurting the environment with it or hurting other people. I spent a lot of time in Agbogbloshie in Africa where I saw people that got really sick from electronics, and I witnessed burning of electronics and that being an entire industry. And I worked with the vice president there to stop that. So I can put a face with this problem, and I've seen people suffer from this problem. And so I'm a big advocate of figuring out solutions here in America for our own waste streams so that we can benefit people with them instead of hurting people from them.
So what do you figure are you like 100% recyclable or 90%? You get a pack in. Of that pack, how much of that eventually gets landfilled or whatever happens to it?
We have a zero landfill policy, so nothing is allowed to go to a landfill. It either goes out to a smelter from my facility, or it gets recycled in-house, or it gets reused. Nothing is allowed to go to a landfill. That's part of the R2 certification.
Okay, all right. So how big do you think that your business is going to end up being? Is it going to, I mean, are you're taking half of the batteries that are available, or, how big, as we get more cars, how big does this potential problem solution become?
We're at the tip of the iceberg now, and the goal is to make sure that we have enough tooling, processing, manpower to actually solve this problem long term. But we can't do it alone. So I am actively recruiting other recyclers to get involved in EV recycling. We're just a single cog in this wheel. Currently, at the rate that we're going, I'm going to need another 100,000 square foot facility in 4 months. And I'm not in the business of storing batteries. I'm in the business of reusing. So it's tough. It's a very big problem, and I'm hoping to share all of our solutions with anybody who's interested, so that they can help us attack that problem and make sure that we can keep electric vehicles. To me, they are the future, and they are any of the naysayers that talk about, when the battery goes bad, then it hurts the environment more than an ICE engine. That's not accurate whatsoever. I can guarantee you that 100% of those packs get recycled in the United States. The issue is, how are we doing that recycling? Are we just going to destroy all of that potential value, or are we going to reuse it in new life cycles so that we can actually divide that carbon footprint by 2 or 3 applications? That's really the question.
Right. So a battery starts off in a car. Then it ends up coming to you, and it becomes a power wall. At what point then, what's the next stage for that?
Okay, so the next stage for that is we put out whatever the product is, and where we put out the product and how we put out the product, we put it into a market where we put a sticker on the product saying, aggregate this product and we will pick it up for free for recycling. So we want to close the loop when it comes to cradle to cradle, making products that are able to be reused. And part of that is the aggregation and the triage.
Right.
How do you master reverse logistics so that you get back all of the material that you put out? And then what can you reuse that for?
Right.
Right. So it's a challenge, but at the end of the day, we are just inundated with batteries right now. I'm drowning in batteries when the rest of the world is starving for them, and that's a problem to me. We need to connect those dots.
Yeah. Well, that's great. I love what you're doing. I think I've been working on a solar-powered electric bicycle rental kiosk.
Awesome.
And of course, we were using deep cycle lead acid, but obviously, I think we'd like to move beyond that. So I think there's an opportunity for us maybe to collaborate beyond just doing this interview. So definitely want to stay in touch with you.
Well, I hope so. That's the whole purpose. I mean, we're here to find strategic partners because we can't fix this problem ourselves.
Right.
So I hope that all of your viewers reach out and help us find the solution to what I don't deem a problem, but an opportunity.
Right. Sounds like a great one. Eric, thank you for taking the time to talk with us and the work you're doing there. That's fabulous.
Thank you very much for your time.
We'll see you sometime.
Anytime. Feel free. Give me a call.
Great. Yeah, I'd love to come out there sometime. So, all right,
yeah,
good.
I'll give you a private tour.
All right, sounds
Come
good.
on out.
Thank you, Eric.
Thank you.
All right, bye-bye.
You've been listening to an EV World Future in Motion podcast with your host, Bill Moore. Be sure to follow me on Twitter and learn more about the exciting world of electric vehicles on evworld.com. This has been an EV World production. All rights reserved.